Alright, today we're going to be going over the antibody screening and the antibody panel. Antibody screens are used to assess whether or not an antibody is present within the patient's serum, while the antibody panels are used to identify those antibodies. Both screens and panels work using the same general concepts, but are used for different purposes. So the positive agglutination reaction means that there's a reaction between the antibody in the serum and the antigens on the cells. But in antibody screens, those agglutination reactions are used to assess whether the presence of an antibody, whereas in a panel, those reactions are used to fully identify the antibody. Now the goal of this is ultimately for you to be able to properly perform the antibody screening, and if antibodies are present in the sample, then you will perform an antibody panel to identify those antibodies. And you can read the objectives yourself, but the basic objective is for you to be able to grade agglutination reactions correctly and be able to run and interpret both panels and screens. Okay, now I'm going to give you 3 questions for you to think about in order to stimulate your thinking about the subject, as well as to assess your level of knowledge before we go over the screens and panels in more depth and actually do the lab. So the first question is, the formation of a well-defined cell button after centrifugation that, once agitated, becomes loose in the tube, staying in one intact clump, is graded as what in the reading of agglutination reactions? A, 1+, B, 2+, C, 3+, or D, 4+. And the answer is D, 4+. If you remember, 1+ is when there's very small clumps with a pink background. And a clever trick is, as the numbers go up, so do the size of the clumps. Question 2. Which phase of the antibody screen or panel procedure do IgG and IgM antibodies best react at? A, IgG reacts best at the immediate spin phase, whereas IgM reacts best at the AHG phase. B, IgG reacts best at the AHG phase, and IgM reacts best at the immediate spin phase. C, IgG reacts best at the incubation at 37 degrees Celsius phase, whereas IgM reacts best at the immediate spin phase. Or D, IgG reacts best after the incubation at 37 degrees Celsius, while the IgM reacts best at the AHG phase. The answer is B. IgG reacts best at higher temperatures, and IgM reacts best at room temperatures. The reason why C and D aren't correct will actually be explained in the next question. So, which class of antibody does AHG bind to? A, IgM, B, IgE, C, IgG, or D, all classes of antibodies bind equally to AHG. The answer is C, IgG. So Hg is short for anti-human globulin, and they're immunoglobulins that are specific for IgG and help to agglutinate cells that have reacted with IgG. And so C and D in question 2 aren't correct because while IgG will react better at the incubation at 37 degrees Celsius phase than it will at the immediate spin phase because it's at a higher temperature, it will react better at the AHG phase than the incubation phase due to the increased agglutination by the AHG. So now I'll start to give you an introduction into the lab activity that we're going to do. You'll be given 2 samples on which you'll have to both conduct a screen and a panel on and identify the antibodies present. So of course during those screens and panels you'll grade the agglutination reactions in order to conduct them. So I'll give you a demonstration of the tube agglutination readings before we start this lab, but I mean by this time in the semester you should already know how to grade these. But the general gist of it is you gently tilt the tube and or roll the tube between your fingers until the cell button is fully resuspended. But you have to be careful not to be too rough with it, or else your readings will be inaccurate. So this is a nice picture of the tube agglutination reactions and the grading of it. If you remember, 1 is the small aggregates with the red background, whereas 4 is the big clump. Remember, there should be no button left at the bottom of the tube. And also remember that hemolysis is a positive reaction, though you'll likely not see that in the antibodies screens and panels, as hemolysis is usually due to the activity of complement rather than the activity of immunoglobulins. So for an antibody screen, there's 3 vials of reagent cells called screening cells, which will be centrifuged with the patient's serum after 3 different things are done with that serum and the cells. So they'll be centrifuged immediately after being mixed together room temperature, after incubation at 37 degrees Celsius, and also after being mixed with AHG. Of course, after each centrifugation, you'll grade the reaction. And the way this works and the way this helps out is each vial has different antibodies present. So since there's only 3 vials, and each one has different antigens present on the cells, you'll be able to identify if an antibody is present. You'll be able to identify which class of antibody is present and the number of antibodies present, but you will not be able to identify the antibody present. For this to actually identify the antibody, you'll have to conduct a panel, which we'll get to. But to identify if there's multiple antibodies present in the serum, you'll either see in the same phase of the procedure, either immediate spin or 37 degrees Celsius or the HG, you'll see multiple different reaction strengths for different screening cells. So for example, you would see a 1+ in one screening cell and a 4+ in another. This would denote multiple antibodies present. Another way to see multiple antibodies present is to see the same strength of agglutination present and different phases for multiple different screening cells. So, for example, you see a 4+ for the immediate spin phase in screening cell 1, but you'd see a 0+, or you'd see a negative reaction, or a 1+ for Hg for the screening cell. But then on a different screening cell, you would see a 1+ for immediate spin and a 4+ for Hg. That would denote two different antibodies of two different classes, because IgG reacts best at the Hg phase and IgM reacts best at the immediate spin phase. So this is an example of the results of an antibody screen, minus the immediate spin and 37 degrees phase. But it'll be a good example of what you do with the results after you get them. So you see here by the red circle that there is a 3+ positive reaction in all three screening cells. And I've circled in red, where to look at. So use the chart to see which antigens are positive for all three screening cells, because the antigen needs to be present on the cells for the antibody to react to. So if you have a positive reaction in all three screening cells, you need to look to see for which antibodies the antigen is present on all three screening cells. If the antigen is not present on one of the screening cells, it's at the very least highly unlikely that it's the antigen. So this identifies, and I've circled in red, which antibodies are the possible antibodies that we'll be looking for in the antibody panel. So when you get to the antibody panel, you'll get 10 vials of reagent cells called panel cells, and they'll be centrifuged with the patient's serum at the same phases as the antibody screen. At room temperature, after incubation, and after being mixed with Hg. Each vial has different antibodies present, but because we have 10 vials, we can look at the pattern of the reactions and actually identify the antibody present. And you identify the antibody present by using the ruling out procedure. So you rule out in two different ways. So if the antigen is present on one of the panel cells, but no agglutination occurs, the corresponding antibody can be ruled out or crossed out. But you need 3 different reagent cells showing no agglutination in order to rule out the antibody. And remember, you cannot use heterozygous cells for the rule out. Similarly, if the antigen is not present on the cell, but agglutination does occur with the serum, then the corresponding antibody can also be crossed out. And again, you need 3 different reagent cells showing agglutination in order to rule out the antibody. And you cannot use heterozygous cells for the rule out. So here's an example of the antibody panel, and I'll also give you an example of the ruling out procedure. You see circled in red is the panel vials that the serum reacted to. I've circled where you'll find those. In this case, all of the positive reactions happen within the AHG phase. So if you look at the red, it's where the antigen and the serum in the antibody, it's where there is no agglutination reaction. So that's in the red. If you look at these, you cross out where there's positives in the serum antigens, or in the cell antigens. If you look at the green, that's where there's a positive reaction, and for that you cross out where the negatives are, where there aren't any antigens present on the cells. Remember, you need at least 3 crossed out vials for the antibody to be ruled out. So we'll need to do this for all 10 of the rows. Now I'll go through the post-test questions. So reading the agglutination reactions, what grade is denoted by a large number of small to medium sized aggregates with a clear background? A, 1+, B, 2+, C, 3+, D, 4+. The answer is B, 2+. Question 2. In an antibody panel, the panel insert table shows the cells of 3 panel cell bottles to be positive for both the M antigen and the N antigen. When conducting the panel, no agglutination is observed with these panel cells. Can anti-M be ruled out, and why? A, no, you need more than 3 panel cells for anti-M to be ruled out. B, no, these panel cells are heterozygous and therefore cannot be used to rule out. C, yes, no agglutination with 3 panel cells positive for an antigen is sufficient to rule out an antibody. Or D, you cannot, this cannot be decided without more information. M and N are unrelated, therefore heterozygosity is unknown without more information. The answer is actually B. So these cells are heterozygous, and therefore you can't use it to rule out. It's a common mistake that students make, so make sure you keep an eye out for that. Post-test question 3. In an antibody screen, how do you tell if there are multiple antibodies present within a sample? A, in the same phase, multiple different reaction strengths for different screening cells. B, 4+ agglutination present in different phases for multiple different screening cells. C, for one screening cell, depending on the phase, there are different strengths of agglutination. Or D, only A and B. The answer is D, only A and B. The reason C is wrong is because different classes of antibodies have different reaction strengths at different temperatures. So if you remember, IgG reacts best at 37 degrees Celsius, while in HG, while IgM reacts best at immediate spin. So for one screening cell, you will have different strengths for of agglutination depending on the temperature. For example, like an IgG will maybe be 1 plus or even a 0 at immediate spin, but will be more strongly positive at the AHD phase. So for your homework, here's an example of results for an antibody panel. Do the rule out procedures to identify which antibody is present, and we'll discuss the answer on Monday. Thank you. See you in the class. If you have any questions, feel free to stay after and talk, or contact me at ksutter@augusta.edu. And remember, give blood, saves a life.